Hello, this is Mr. Gilmore with the 3.6 Triangle Congruence Proofs. Now that we've reached our end of the chapter, we're going to be taking a look at using our triangle congruences, side angle side, side side side, and angle side angle to prove that two triangles are congruent. So through this next several slides, we're going to take a look at several examples and also trying to look at pattern of what we can find to help us reach congruence within several different pairs of different triangles given to us. So for example, in our first example, if we're given a pair of triangles such that they share a side, we like shared sides because with shared sides, we can prove or we can grab equal things from that pair of shared sides because everything is equal to itself. So be on the lookout for shared things. Well, we're going to see a shared angle later on in the slides, but right now we have shared side. What we can do with that shared side is use the equality from that to help feed congruence. So our goal is to prove that these two triangles are congruent, either using side angle side, side side side, or angle side angle. Let's take a look. AB is equal to BC, so I'm going to go ahead and mark that on my diagram such that AB is equal to BC, and that BD bisects our segment AC, which then means we could claim in our proof that AD is equal to CD. Lastly, we're going to fill in our congruent statement of if I want to prove these two triangles are congruent, well, ABD is congruent to what? Well, it ends up being triangle CBD is the corresponding triangle that we're going to prove to be congruent. Now, I'm not going to do the entire details of the proof with you, but I'm going to show you kind of several examples of what to be on the lookout for. So you can put together the proof for this very simply, but I'm going to show you that be on the lookout for shared things. So a shared side, for example, these two triangles share the segment BD, which means in my proof, I can declare that those two triangles are in fact congruent by now side, 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 because I can feed it the equal pair of sides given, AB equals BC. I can feed it the equal pair of other sides that we can state from the definition of midpoint, AD is equal to CD, and then claiming BD is equal to itself, we've got our common side, which then means, yes, we have a pair of congruent triangles by side, side, side congruence. Now, there's another way of actually taking a look at this one. I've had some folks ask, well, could I have also used side angle side? Yes, you could have. We're given, right, that ABC here, we've got AB is equal to BC, and if angles appear straight, they are straight, which means I could use ITT to prove that angle A and angle C are equal to each other. So combination with ITT and side angle side, we could prove that those two triangles are congruent. So there's another way we could have done that. In this case, though, the shared side is the quicker way. Grab the shared side, bam, we've got triangle congruence. Let's take a look at this one. Dual midpoint. We love midpoints. Be on the lookout for them because if we have midpoints, midpoints cut things in half equally, and we love equal things. So as we dive into this one, C is the midpoint of both of the given segments, AD and BE, which means in my proof, I can claim that AC and CD are equal. I could also claim that BC and CE are equal. So in my proof, whether paragraph or in column form, I'm going to have to state that I know that those are equal by the definition of midpoint. Well, to prove this, then, ABC is congruent to what? I've got to match up my corresponding parts. A would, in this case, correspond with D. B and E would correspond, and C would correspond with self. So now I have two sides of one triangle equal to two sides of the other. What else do I know? Well, angles that appear straight are straight, which means, yes, indeed, we have a pair of vertical angles, and by VAT, we know our vertical angles are equal. So in my proof, I would state that I know my vertical angles are equal by vertical angles theorem, and then from that, I do have enough then to declare these two triangles are in fact congruent by side angle side congruence. So again, be on the lookout for midpoints. We love midpoints. Let's do a similar example. Let's say we just have one midpoint this time. At this time, we have an equal pair of angles also given to us. So in our given, and same diagram actually, in our given, we have angle B and angle E given to us, but we're also told that C is a midpoint of just one segment. It bisects segment BE, which means I could claim BC and EC are equal. Well, what else do I have then to claim equal? I'm actually proving the exact same set of triangles are congruent. Again, I have angles that appear straight are straight, which means I can claim my equal pair of vertical angles. So in this case, we still can prove the two triangles congruent, but we're going to conclude with a different triangle congruence this time, angle side angle congruence. So whatever details you're going to add into your proof, whether paragraph or column, you're leading into angle side angle congruence. So make sure when you're doing proofs on this last worksheet that you're getting all those details in to feed the correct congruence. Dual angle bisectors. Be on the lookout for angle bisectors. We love those because they cut things in half and they give us equal things. Again, we're going to try to prove two triangles are congruent. We've got triangle ABC is congruent to triangle ADC. No, excuse me. ABC is congruent to angle ABD. There we go. We're given that AB is actually a dual angle bisector, meaning it's cutting each of the pairs of angles in half, which means in my proof I can claim that DAB and angle CAB are equal, and angle DBA and angle ABC will be equal as well. And I can claim that on my paragraph proof or in my my 3-column proof, however you want to lay the details out. To finish our proof off, though, all right, I've got two pairs of one triangle equal to two pairs of another. I need actually a side, and in fact, I need the included side, and we have that. I can claim AB is equal to itself, right, by reflexivity of equality. Throw all those into the pot, we've got angle, side, angle, then we can prove that these two triangles are in fact congruent by angle, side, angle. So again, I'm not going to go through all the details of each proof. I'm going to let you guys, kind of go through those proofs on your own, but you do want to feed congruence, so be on the lookout for some of these details: midpoints, angle bisectors, given angles or given sides that are equal. Also be on the lookout for isosceles triangles, right? Those give you equal things now too. Now, of course, in many cases, once we achieve congruence between two triangles, we can then invoke CPCTE, right? We send a reservation or an RSVP to Congruence, and we give him a +1. He always brings CPCTE as a +1 with him. So if we have congruence then between two triangles, we can then state we know more things about those congruent triangles, stuff that we have not known previously. We could either grab an equal pair of angles or an equal pair of sides by actually using CPCTE in our next step of our proof. So you're going to see that, yes, we're going to arrive to some congruence between two triangles, but then I'm going to take it one step further and actually then grab what I need. Is it equal pair sides, equal pair angles, from using CPCTE? Let's take a look at this example here. We have triangle ABC such that D and E are on the segment AC and BD and BE have been connected. We are given that AB is equal to BC, and that these two smaller segments here, AD and CE, are given to us as being equal as well. We are going to prove that BD and BE are equal segments as well. So how do we get there? Our venture is through congruence. I already see that I have two triangles here. Let me point them out to you. ABD, that triangle there, and CBE, that triangle there. I can prove those triangles congruent. I already have two sides of one equal to two sides of the other. Where am I going to get either my equal pair of third sides? Well, I can't get that equal pair of third sides because that's what I'm trying to prove. But what I can get is an equal pair of angles. Take a look. In my proof, I can grab that angle A and angle C are equal to each other. We know by our given that we have an isosceles triangle, which then means I can claim that those two angles are equal by ITT. Of course, however you lay this out, paragraph form or in our column form, you're still going to need to make sure you list out that reason in your proof as you are reaching into your proof statement. So now what we can do, we can actually claim congruence between two triangles. ABD is in fact congruent to triangle CBE, and we know that by side angle side congruence, right? I've got two sides in the included angle of one equal to two sides in the included angle of another. What I can then finish off with is grabbing exactly what I want. CPCTE comes to the party, and he brings equal things with him. We want those pairs of equal sides. As it turns out, they are in fact corresponding with each other. So I can claim BD is equal to BE by invoking our new best friend, CPCTE. Corresponding parts of congruent triangles are equal. So there we have it. We've got the equal parts there. Let's do another one. All right, let's take a look at these two triangles here. It's hard to see the two pairs of triangles. I'll actually show you here in just a second. But what we're going to find in this case is we have to still go through congruence to get to our conclusion. We want to prove that BD is equal to CE. Well, I need to prove then a set of triangles are in fact congruent, because then CPCTE will come to the party and grab those equal pair of things for us. So we're given that angle B and angle C are equal, and we're also given that the entire length AC and the entire length BA are equal. Now, what can I then do with this? Well, as it turns out, we do have two triangles in here. They're really hard to see. Let me point one out to you. ACE and ABD. That is actually two pairs of triangles that overlap. And we like when triangles overlap. They either share a side, or in this case, they share an angle. We can claim angle A is equal to itself, which then means we have enough to declare congruence between the two triangles, right? We have triangle ACE now, is congruent to triangle ABD by angle side angle congruence this time. We're given, we already had a pair of equal angles, we're given a pair of equal sides. As it turns out, they're a pair of included angle, or the included sides, and then with angle A being reflexive, right, which means it's equal to itself, we've got angle side angle between those, which again means we can invoke our best friend CPCTE to come to the party as well. So we bring CPCTE, and we can claim then BD and CE, which happen to be corresponding. If we take a look at our congruence proof, look, CE, our congruence statement, CE, BD, they correspond exactly with each other. So we've got ourselves a equal pair of corresponding parts with those congruent triangles. So be on the lookout, right? Your proof statement may not explicitly say prove these two triangles are congruent, but to get to a pair of equal things, we can pass through congruence and then invoke CPCTE to grab those congruent things. Now, our last example is going to be a special one because in many cases, or in some cases, we may be given congruence, right? If I have congruence already established, then I can already go ahead and invoke CPCTE. So the last several proofs, we prove congruent triangles, right? We had to arrive to that conclusion, but then we can take it a step further. Well, in some cases, we may be given congruence between two triangles. You may have already, congruence may have already been established for you, which means right off the bat, you can invoke CPCTE with the information we know about those two congruent triangles. Let's have a look at our last example. So in this last example, take a look at our diagram, kind of a funky looking one, right? We've got these two triangles, ABC and CDE, such that F and G are marked on AB and DE, and then C is connected to both of those points. Well, as it turns out, we're already given that in our diagram there is a pair of congruent triangles. Take a look at our given. Triangle AFC is in fact congruent to triangle EGC. So let me mark those. Here's AFC, and here is EGC. So from that, we can already draw out of this statement many other statements of implication. We can draw out equal pairs of sides, we can draw equal pair of angles based on those corresponding parts, and we can invoke CPCTE right from the beginning. We're also given several things about F bisecting AB, which means it's the midpoint, and G bisecting DE, which means it's the midpoint. So what can we do with that given information then to arrive at the conclusion? We want to prove that there's another pair of congruent triangles here, BFC and DGC. Well, again, I'm not going to go through all the details here, but here's how I would approach this. It's nice knowing that the triangles that are given to us as congruent already share some parts with the pair of triangles that we want to prove are congruent. For example, if we take a look, triangle AFC is congruent to triangle EGC. One thing I want to grab out of that is already knowing that from that, CF and CG are equal to each other. So I can claim that CF is equal to CG by invoking CPCTE just from the beginning. Now be careful, I can only invoke the information that I gather right out of the given congruence. I can't just grab any pair of equal things. It has to come from the congruence. So there's 6 statements I can grab. I have to be very careful not to grab any statements that are not included in those 6 statements. I can grab all 3 pairs of equal angles, and I can grab all 3 pairs of equal sides. But those are the only things I can grab out of that specific congruence. So what else can I do? Well, I'm also going to grab that AF is equal to CG or EG. I know I can do the exact same thing from that congruent statement. I can grab AF is equal to GE, same invocation. And I know that there's one other thing I want to grab. There's actually a pair of equal angles that I have here. Oops, wrong angle. CGE and AFC, these two angles are equal to each other. I can grab those pair of equal angles. So I can grab AFC is equal to the measure of angle CGE, and I can invoke it from the exact same thing. Because I'm given congruence, I can invoke CPCTE right off the bat. So now where am I going with this? I have to relate things between those two triangles, BFC and DGC, so I arrive at congruence. Well, take a look. I already have one pair of equal sides given, right? I've got CF and CG. All right, CF and CG. I can then say that I have one pair of equal sides. I need something else. Well, using some of our part-whole theorems, right? Actually, sorry, not part-whole theorems. I can actually use transitivity equality here. I already know that AF and FB, since F is marked as a midpoint, I know that A are given as midpoint. I can claim AF and FB are equal. I can also claim that DG and EG are equal because G is a midpoint. And since I've already invoked AF and GE are equal, then by a very big happy family of transitivity, I can grab the fact that BF is equal to DG, which then means, right, this is a transitivity of equality, which then means I know I have two pairs of one triangle equal to two pairs of sides of one triangle equal to two pairs of the sides of another, right? I've already got CF and CG, now I've got BF and DG. I need one other thing. I either have to prove CB and CD are equal, or I can grab the included angle between those two pairs of equal sides. I'm going to go that route. I can actually claim that the measure of angle CFB and the measure of angle DGC are going to be equal. Now let me explain that one. I'm claiming this. Okay? There may be some details you may need to start off with moving into that, but I can claim this. Here's why. I know that the entire angle pair between AFC and BFC, those two angles together form a straight angle, which means they form a linear pair, right? So I know that they are supplementary to each other by the linear pairs theorem. Same story on the other side of my diagram. DGC and EGC also form a linear pair, which means they're also supplementary by linear pairs theorem. What can I then do with that? Well, I have two angles that are equal, AFC and EGC. The other pair of angles are each supplementary to a pair of equal angles. Well, if two angles are supplementary to a pair of equal angles, then I can prove that those other two angles, DGC and CFB, are equal to each other. It's kind of like a variation of the same supplements theorem. Same supplements theorem says that if two angles are supplementary to the same third angle, then they are equal to each other. Well, I'm changing it just a smidge by saying two angles are supplementary to a pair of equal angles, then those two angles themselves have to be equal as well. What that gives me then is enough information to claim congruence between those two triangles. So now I can say triangle BFC is in fact congruent to triangle DGC, and that is by side angle side congruence. So that's using, in the beginning of this proof, invoking CP/CTE right off the bat because we were given congruence. Now, of course, there's a lot more detail to this proof. I just kind of went through the proof overview, and there are many ways of proving the same result, which means you may have seen a different route in arriving to the conclusion that BFC and DGC were in fact congruent to each other. So again, how you approach your proof, you may have a different route to take, but remember, proofs just simply take us from the given conclusion. That doesn't mean that there has to be X number of steps to it, right? You could have more or less steps than I do, as long as it logically completes, right? It's logically complete going from one step to the next. Please be sure to check out the 3.6 worksheet. It is a bit of a long one. You've got lots and lots of examples to actually do on that. If you do have any questions for me, please email me. With that, be good and do good.